Hello, and welcome back to Learning with Lee. In today's episode, we are going to begin to take a look at inputting and outputting values using C. We're not going to get into C++ or any more advanced languages at present. We'll be getting into those in a few episodes, but I want to start from the beginning so you can see how those other languages have improved on C, what they've changed, as well as also how they're similar to C and what they've taken from C and in general improved upon. So to begin with, the first thing you can do is you can either just get a char as input, or you can output a char. And this can end up being from a fair number of different sources. However, in general, you're going to see it either from your command line like this, or in this case here, what we're going to be using is the console here. Just to show that I could end up, if I wanted to do this, I could go, okay, intro.exe, and one of the things that is important to note is that in case you're following along with this series, it does actually build an executable for you to run when it does the whole build process and the run process and output stuff to your console. So you can actually execute that from a command line. You could double click on it if you want, though for most of what we've covered so far, that would be completely pointless unless you had a command line open. So I could go, okay, here's this, input a certain value, and then do this again, and you see what we're doing in these demos is we're just taking some input and finding the square root of that input. And the reason why we're doing that twice is to show a bit of a difference between how you do it with this most basic version using characters and a more advanced version using formatted strings. And we're not going to get too much into formatted strings in today's episode, just because it's a very broad topic that deserves its own entire episode dedicated to it. However, it is valuable to see the difference between it and the character version, because the character version, while simple, is not something that you want to use too much of, because it forces the rest of your code to be extremely complex to make up for its simplicity. So, in case I wanted to, in this case here, let's say, read in that series of numbers, such as, in this case here, I read in 1, 2, 3. What I have to first do is I have to use getchar to grab characters until a certain point. And getchar will basically block, and what that means is it'll cease, basically cause the rest of your program to stop executing until it receives a value in. And there are ways in which you can do that asynchronously, so as that you can basically begin reading values while you're still processing on other things. However, we're going to get into those in the future once we get into stuff such as multi-threading, and how to deal with that once we get to operating systems in particular. But for now, it just goes, okay, I end up running this. I want some value here. I need to be able to read in those numbers 4, 5, 6, and I need to stop. In this case here, I'm stopping at the new line character, as you can see in here. And later on, you'll see some slightly different stuff for how we do it down here. But this happens to be a good enough one for now. It's not something you'd ever do in practice because of the fact that what if it happens to be, for example, a period? Or what if it's a space? Right now, what our current one is doing is it will just continue to go through whatever you supply it, and if whatever you pass in is a digit, so I could do something such as 1, 2, 3 space 4, 5, or 4, 6, 5, and what I would end up getting out is it would assume that the number I passed in was actually this number. It would ignore the white space in there. If I put in this and then had a decimal point in it, it would ignore that decimal point for how this currently is. So you can see that it would even require it to be more advanced in order to handle some of those more complicated input types. But for now, we're just going with a very simple demo of it just to show how ugly it is, even in just this simple version. So if it's a digit, we then have to convert it from a character to an integer. And technically, this ends up taking in a string of characters, so in case I had some string, such as 1, 2, 3 here, I could actually supply that into A2I, and it would generate out the value 1, 2, 3, without any real problems there. However, in this case here, because we're reading one character at a time, we're just going to do this. Technically, what we could do is we could sort of aggregate this into a single string in case somewhere up here, for example, I had buffered some amount of memory for that character array or the like, And I could use this on that character array as I keep putting in these and just stop as soon as I hit a non-digit value. And then use A2Y only once. And really that's up to you. In general, you're never going to be doing this in this way because there's cleaner ways to do it. And that's the whole point here. This is a very ugly way, and it's a very inelegant way. And then, of course, once you end up converting it to an integer, you then, of course, need to shift whatever total you had previously. So we start out at 0, but let's say that we start out at 10. Or even simpler, let's say I start out at 1. Let's say that I've already received an input, and we've gotten the 1 here from this 1 down here. Now I need this 2. It's going to wind up in the tens place. But before that, because I don't know how many digits are after that 2, I need to shift this 1 tens place to the left. So it needs to go to, in this case here, the tens place, so times 10. And then we need to add 2 to it, so that 2 gets into ones place. And then once we have 12 in there, we need the 1 to go to the hundreds place, the 2 to go to tens place, and so on. And that requires us to multiply it by 10, and then we add in the new character, 3. And it gives us 123. So that happens to be why this line is here for it. And overall, that's a very inelegant solution to this entire problem for what we're actually dealing with here. Then we just take a square root of it, fairly simple, using the C standard library version of the square root function. Nearly every single language has a square root function somewhere in it, in one of its standard libraries. C++ has its own one, Java, C#, they all have their own ones. And then we're going to call something to output it. So this is basically all you have to do to read in a character, this line here in particular. And in case you're wondering how you can do this, in case you want to follow it along at home, you can just run it from within here. You don't have to go to a command line like I was showing you. That's purely optional. And then I could do something like 1, 2, 3, get that. 4, 5, 6, get that. And that is a perfectly fine and easy way to do it. For more advanced things, you actually will probably want to advance to the command line. Especially once we start dealing with file I/O, it'll be a bit cleaner that way, because then you'll have a better understanding of where your executable actually is, as well as where whatever files you're operating on happen to actually be, relative to that one. But we're going to be getting into that once we get into files, which is still a couple episodes away. So, now that we have figured out the square root of reading in these values, we need to output that square root. So, down in here, and this is split into really two different functions here. And this one down here is a recursive one that, you note down here we have a certain problem. Imagine trying to output this one character at a time. How are we going to figure out what the first character is in terms of just outputting this one over here, and then outputting this one here, then outputting a decimal point, then outputting a 9, and so on and so forth? How are we going to figure that out? Well, one of the important things is that we can figure out whatever digit is in this spot by using the modulo operator, as well as then also by using the division operator. Because in case we take the modulo of the square root of 123 by 10, but let's even say we take the modulo of 123 by 10. It's going to give us a remainder of 3, and it's going to give us a quotient of 12 for when we do that division. And then we divide 12 by 10, it's going to give us a remainder of 1, a remainder of 2, and a quotient of 1. So we can end up dividing up the numbers that way. However, we end up getting them in the reverse order. So that's an easy way of understanding it for this section here, and we'll get into exactly how we deal with that reverse order problem in a second. But for now, there's one other problem, and that's that works fine for an integer. However, it doesn't work for when we have this decimal in here, because doing the division operator and the modulo operator works fine when we have an integer here, but it does nothing for us with this value down here. So the trick to that is that basically we treat each of these values, this 11 and this 9053, as integers, or in this case here, long values. And we just use the exact same operations, this function down here, on both of them. However, to split them up, and this is a very simple thing you can do, you have to figure out what's before the decimal and what's after the decimal. And the way you do that in programming is that you have some double value, then you convert that to a long, or an integer, or a short, or something else, and that'll give you whatever's before the decimal. It'll truncate it and cut off all of this. Then what you can do after that is you can subtract whatever you get from converting it to an int or a long from the original double. And that's going to leave you basically with 0.9053 in this case. Then what you have to do, though, because you're going to convert that to a long, and normally this would just get truncated down to 0, is you then have to multiply it by however many digits after the decimal you want to preserve. In this case here, I'm passing in 5. So basically 10 to the 5th is going to end up shifting the decimal place here over 5 spots. And that's going to end up allowing me to go, okay, how much do I actually have in here? So it'll give me 90530. And down in this portion here, we end up actually cutting off the 0. There are ways in which we could avoid doing that, but for now, this is just a demo, so it doesn't really matter one way or another. What we then do is we print out the portion before the decimal point, print out the decimal, and print out the stuff after the decimal. And we only do this section if there's actually anything that comes after the decimal point. If it's all zeros, then good for us, we don't really care about that. And for an example on that, I can just run this and put, oh, whoops, that's actually good. Oh yeah, that worked out fine, good. And then we have 144 goes to 12, but in case we go with something different, it ends up still having the stuff after the decimal point. And then we put in a new line because otherwise this line here winds up right after it. So down in here, what we're actually doing is, just as I said, we end up finding the remainder in the quotient, and then we end up recurring. And the order of this is very important, because basically, if I put this character here before I put this character here, it's going to put down the reverse order. So if I had this putchar before I recur into this, it'll go, okay, let's output the remainder, then we'll find the next value. So it would output, in case I did this on 144, it would output this 4 first, then this 4, then this 1, which obviously is a problem. So the trick to solving that is that you recur first, so that the first time we hit this put character function, it ends up returning, basically, in this case here, it will return whatever happens to be the last one we recur into, which is the first digit, so the largest digit. In this case here, it would be this 1 for 100, then we'd hit the 4 for 40, and then we'd hit this 4 here. So that's why we do this recurring before we do the putchar. Because what I'll do is you'll go, okay, before I can execute this statement here, I need to go through this one, and then I need to go through its one, and then I need to check the next one, but its value is 0, so we just return up to that one. I continue executing, hit this first putchar, then return up to its whatever called it, hit this putchar, and so on and so forth, back up through the chain. And that's how we end up doing that, and this ends up working for both what we have before as well as what we have after the decimal point. So that happens to be fairly easy, I think, in order to understand it. You might need to spend a bit of time just proving it out for yourself, because I understand that just saying, oh hey, this happens to be how you do this, isn't necessarily the best way of showing it and getting to feel it. So I'll have this code up in the description, and you can end up looking through it and trying it out for yourself and spend some time messing around with it and confirm it so that you can understand why this operates the way it does. So that's how we would actually do inputting a number and getting output the square root. Now here's a bit of a cleaner way to do it, and this is what we're going to look at in the next episode. And this is how you do formatted stuff. And for this, there's two different functions we're going to start looking at, and that's the scanf, or scan formatted, and the printf, or print formatted. Really, you could say scan formatted string or print formatted string, but really there's some variations on it, like if I did scanf, and what that does is it scans a string, or fscanf, and that scans a file. So as you can see, understanding scanf and printf is pretty important to understanding how all I/O takes place in C. So all you do with this is you read in some value, and there's a whole bunch of different things, but basically they all start with this percentage saying, I'm going to read in some particular value. In this case here, LF stands for long float, which is just another word for double. So if I had this as a float, I could take in an F here. However, it is important to note that with this as a double, I cannot forget that L in front of the F, because in case I forget that, and now let's say I do this, you can see that earlier one works, but now, all of a sudden, when we end up hitting this section here, it doesn't work, which is a bit odd because it was just working. However, scanf is, as well as to a certain extent printf, are so low level that they are dependent on the binary representations and the differences between things like floats and doubles. So when you end up using one as opposed to another, whether you use float or L, and we'll get into what all the different ones are in the next episode, because there's a fair number of them and they're very useful to understand. If you use the wrong one, it'll end up putting it into memory incorrectly, and it will end up screwing out pure output. So now that I've fixed it, we can do this again, and we can go 144 and 144, and you can see that gives us the correct value down here. And all that we have to do, as opposed to going through all of this shenanigans in order to output it, as well as technically all of this shenanigans as well, is we just have to make this single call to printf, specifying that we want to print out a long float. Now, the important things to understand about scanf and printf for just today's episode are that scanf takes in a pointer, and that's because, as you might remember from us going over pointers originally, we're calling a function here. And if we pass in just the value of this double here, it's just going to copy it, and it's going to be a local copy. It's not going to be able to modify this original double out here. So we have to pass in a pointer to that double. You view it as passing in a reference because we're passing in using the ampersand here, but really all that is it's a pointer. And then down here, it doesn't matter if it's a copy, because in here we're not going to be modifying whatever we pass through to printf. We're only going to be modifying it in the case of scanf. So that's really all I want you to see, is that these are significantly cleaner than all of this is for how we ended up outputting just single characters and inputting single characters at a time. There are times you want to use getchar and putchar, however, they happen to be significantly rarer than times that you'll end up using scanf or printf or their equivalents in higher level languages, which we'll get into in a bit. So, thank you very much for watching. Have a wonderful day.